continue from where the video left off. We're going to kind of review a couple of things real quick that are in the video, but continue from where the video left off in our examples and actually finish out the partial fraction decomposition. So when you have those constants, A, B, C, whatever those may be in your numerators, we're going to figure out what those actually are and then plug numbers back in. So I talked about in the video yesterday, like the whole goal here is to make a complex rational function separated out into the sum or difference of some simpler rational functions. So thinking ahead to like where you might use partial fraction decomposition in calculus, if you can take something more complex and make it a little bit simpler by separating it out, you can do more things with it. So the first slide has just a list of some of the steps that you went over in the video yesterday. So I would imagine if you took notes from the video, you kind of jotted these things down on that slide. So decomposition of a rational expression into a partial fraction includes step 1, factoring the denominator. Everybody did that in our warm-up. Okay, so we got to use our factoring skills. Step 2, write the decomposition. Here's that first bullet point, just like that second example in the warm-up. For any repeated factors, those are factors that appear more than once, include the lesser powers of that factors. You're likely going to come across some that are squared, and so then you need to include the power of 1. Okay? If you have a linear factor, then your numerator will just be a constant. We start with A, and then we just go in alphabetical order, so we use A, B, C, D as needed. For a quadratic factor, your numerator is going to be linear, and I went over that in the video on the very last example. What I remember for my numerator being linear is I want to write it in the form mx plus b, but then m and b are going to change to be those different letters of the constant. So if it was the first one that I was writing, I might be like ax plus b. Or if I've already used a, bx plus c, a cx plus d. So I'm just substituting in those constants for the m and the b. And then always remember, don't repeat any of your constants. So leave all of those constants. Every time you write a new constant in the numerator, use a new letter. Okay. Now what we're going to concentrate on today are steps 3 through 4. So step 3 is going to be simplify. And how we're going to simplify today is a method that you used for solving rational equations back in Algebra 2, and that's called the LCD method. So what we're going to do is we're going to look at what's the least common denominator. It's basically the denominator you started with. You're going to multiply that across the whole equation. And what that is going to do for you when you multiply by the LCD is eliminate all the denominators so things don't look like fractions. So we like it when things don't look like fractions. That's going to be our first step that we'll go on with today. Okay, so simplify, which means multiply by the LCD to eliminate your denominators. After you do that, you'll be able to solve for your constants. So we actually want to figure out what is that A, B, or C equal to numerically. Now, I do have a hint for solving for constants, and my hint is choose the zeros to substitute. So when I'm talking about the zeros, I mean like the zeros of the factors that you were working on. So if you had had a factor of x minus 3, what is the 0 of x minus 3? X equals 3. So a hint for us to make it a little bit easier to evaluate or to find is choose those zeros. Now, we'll see an example where just zeros won't get us what we want, so we'll have to think of some other things. But if you can find the zeros of the factors, use those. And then finally, you'll be able to solve for the constants. You might involve thinking about it in terms of a system, but then you can plug in to the final product and you have a decomposition. Okay, so you'll actually plug in those numbers for your constants. We have 3 examples that we'd like to run through, and our first 2 examples are going to be the examples from the warm-up. So we already know how we would set up example 1. It's x plus 8 over x squared plus 6x plus 8. In the warm-up, we factored the denominator, x plus 4 times x plus 2. And then you guys said both of those were linear, so we would have constants for our numerator. A over x plus 4 plus b over x plus 2. And it's okay if you write a over x plus 2 plus b over x plus 4. Our a's and b's would just be switched. So we've completed step 1 and step 2. Step 3 is now new to us, and that is to simplify this equation, because this equation has fractions on both sides. We're going to multiply by the least common denominator for all three fractions. And really, the least common denominator is going to be the denominator that you start with, because that's the one that has all the factors. So we're going to multiply the entire equation by x plus 4, x plus 2, and that means that every single fraction gets multiplied by x plus 4, x plus 2. Like distribution. Every single fraction gets multiplied by the LCD. After you multiply by the LCD, you can go through and start canceling out common factors in the numerator and the denominator. Every single term in that equation now has the x plus 2, x plus 4 in its numerator. And for this very first fraction, that's going to cancel out our whole denominator. So the only thing that's left over on the left side is x plus 8. Move to the other side of the equal sign. In that first fraction, we'll only be able to cross out x plus 4. So we're left with a times x plus 2. And plus, we'll be able to cross off the x plus 2 factor in the numerator and the denominator. So we have b times x plus 4. And that equation looks a lot simpler than the previous equation because it doesn't have all the fractions. So I'm feeling more confident in my ability to solve for a and b, but I'm still looking at that like there's a lot of unknowns right there. I don't know x, I don't know a, and I don't know b. How am I going to solve for any of those? That's where my hint in step 4 comes. Okay, my hint in step 4 is choose wisely what your x is going to be. Because if you choose a number to 7 for x, then x will no longer be unknown. Okay, you'll choose an x value. And if you choose wisely, if you choose one of the zeros for the constants a or b, that's going to make that factor equal 0, and then a or b is going to be multiplied by that and equal 0. So I would start by letting x equal -2. So let x equal -2. Now I just have to go in and plug -2 everywhere I see x. So on the left side, -2 plus 6, or sorry, -2 plus 8 would be 6. Then I'll have a times 0 plus b times 2. And a times 0 is just 0, so I really have 6 equals 2b. And b must be 3. Now I can use the same method for the other. If I want to solve for a, now I'll let x equal -4. Okay, so think about, like, we just let x equal -2, and that made this equal 0, so then a was also equal to 0 when it multiplied by 0. Now we're going to let x equal -4, which is going to create this b to multiply by 0 and then go away. So let's let x equal -4. 7 everywhere you see x, so on the left side, -4 plus 8 is 4. A times -4 plus 2, that's -2. And then b times 0. Well, b times 0 is just 0, so I really have 4 equals -2a, so a is -2. And the last step, after you solve for those constants, we now know constant a is always -2, constant b is always 3, is to then write the final decomposition. So so sometimes, and I'll do this on this one, is I'll write out the whole statement. So the whole statement said x plus 8 over x squared plus 6x plus 8 is equal to, and then I'm going back to that very first line where I have a over x plus 4 before I canceled out with my LCD, and a over x plus 4 and b over x plus 2. Then I'm going to plug in my a and b respectively. So a was negative 2, so I would say negative 2 over x plus 4 plus b is 3 over x plus 2. And I have partial fraction decomposition. If I were to test to see if I were right, I could, on the right side here, multiply this first fraction by x plus 2 over x plus 2, multiply the second fraction by x plus 4 over x plus 4. I'd have the same denominator, and then when I clean up my numerators, they should equal x plus 8. Does anybody have any questions about what we did for that problem? Okay, so number 2, example 2 is the one from the warm-up. Okay, and we already went over this one together. We would factor our denominator. We wrote out our partial decomposition with the repeated factor. So did we say, how do you guys want to write it? A over x minus 1 squared plus b over x minus 1, and then we did the plus c over x, right? Okay. And those could be in any order. It would just mean like if you had a over x first, that your a would actually be rc. Okay, so it doesn't matter how you do it. Will you attempt your step 3, simplify the equation? Attempt your step 3, simplify the equation. So you're going to multiply by the least common denominator. I'll walk around. If you have a question about what you're doing, let me know. Yes. Yeah, I would use the factored form because then you'll be able to cancel out just single factors. Yep. Sarah asked a great question. Should I use my factored form for my LCD? Yes, I would. Some of you may find that you can just multiply the whole equation by x times x minus 1 squared, and you don't have to write it out for every single term, and that's totally fine. And I'm going to show one more time in the example. Every single fraction gets multiplied by that x times x minus 1 squared. That's my LCD. On the left side, that's going to cancel out the entire denominator. Okay? So that should always happen because you're going to multiply by that thing that you started with. And so all that's left over on the left side is 3x squared minus x plus 5 equals. What's left over on the right side? What do you guys have written? A times x plus b x times x minus 1 plus c times x, x minus 1 squared. Okay, so you're thinking about what things will cancel. The x minus 1 squares will cancel. the x minus 1 in that second fraction will only cancel out one of the x minus 1 in the numerator, and then x will cancel here. Okay, so then what strategy would you take for step 4? Is there a strategy you could use? Let x equal 1? Okay, let's try. Let's let x equal 1. Okay, so we're going to have to plug x equals 1 into this entire equation everywhere we see x. And if I were to do that on the left side, 3 times 1 squared is 3, minus 1 is 2, plus 5 is 7. And that's equal to 1a plus b times 1 times 0. I'll write these down. 1 times 0. And then plus c times 0. So we know a is equal to 7. Do you have any other strategy you can use in step 4? You could let x equal 0, right? One of your factors besides x minus 1 is just x. So the 0 for that would be let x equal 0. So again, I got to plug 0 in everywhere I see x. On this first left side, it would just be 3 times 0 squared minus 0 plus 5, which will be 5, equals a times 0 plus b times 0 times negative 1 plus c times negative 1 squared. So negative 1 squared over there with c is going to be 1c, and then both b and a are going to be equal to 0. So we know 5 is equal to c. Okay. So notice what happened in both of those. Everything canceled out except for 1, and what canceled out in both? B. Okay. So in the first one, when we let x equal 1, b cancels to be just 0, and c is also just 0. Okay. Over here, when we let x equal 0, a is getting multiplied by 0, but then so is b. And that's because when you look at your b with what's left over, it has both of the factors, right? It has an x factor and it has an x minus 1. So our whole hint or method there to find that variable or that constant by letting that equal a 0 isn't going to be helpful for b. So what strategies might you now take to find b? I'm going to give you a little bit of time to look it over and see what you know, and see if you can come up with something. Talk to people around you, share your ideas. See what you think you could do. You know A is 7. You know C is 5.
5.
I know. Have we come up with any ideas? Okay, plug in A and C. So do you mean in this blue section?
Yes.
Okay, in the blue section, back where we are always letting x equal 0, letting x equal negative 1 or 1, let's plug in A equals 7 and C equals 5. Yeah, let's see what happens. Okay, so pull that down real quick. On the left side, I don't have an A or C to plug into, so I'm going to have this. say, plug in a equals 7 and t equals 5. So I have 3x squared minus x plus 5 equals 7x plus 3x times x minus 1 plus 5 times x minus 1 squared. Super helpful? No. But maybe better. What could you do next? Abby was gonna say distribute, and that is an option. I will say that's probably like not your most efficient option, but it could work. When you distribute like some of those x's and things, you could come up with a system that you'd be able to solve. It's a little bit more time consuming, and I think there's something we could do that would be a little bit easier. What's unknown to us in this equation? X and b. Which one of those could we sub in for just anything? X, because x is a variable, right? It changes. We've already let x equal 1 and let x equal 0. So now let's let x equal what? 2. Okay, fine. X equal 2. I'm okay with that. Because if we let x equal 2, then the only thing that will be unknown is b. So let's see what happens. Okay, I'm going to have to write this one down. 3 times 2 squared minus 2 plus 5 equals 7 times 2 plus b times 2 times 2 minus 1 is 1. And then plus 5 times 2 minus 1 is 1 squared. And over here, 3 times 2 squared is 3 times 4, so that's 12 minus 2 is 10 plus 5 is 15. That's equal to 14 plus 2b plus 5, which is 19 over there. I'm going to make that 19 plus 2b, but Vaughn is saying subtract 19 from both sides. So negative 4 equals 2b, b must be equal to negative 2. And then you just rewrite the whole thing. Yeah. Now, Grace had suggested let's let x equal 2. We should find the same value for b if we decide to let x equal negative 1. Or let x equal 5. Okay. I try to keep my number small just because then it's easier to work with. So I might choose zeros, 1, negative 1, 2, negative 2, and hopefully that's all I would need to choose from. So let's write out our final answer. What do we have? 3x squared, is it minus x? Plus 5 over, was it x cubed minus 2x squared plus x? The original problem? Minus 2x squared plus x. And then we said a was 7. Is that correct? Over, so that would be x minus 1 squared plus b, which is negative 2. So you can either write plus negative 2 or you could do a minus 2 over x minus 1. And then c was 5, so plus 5 over x. So there are some partial fraction decompositions where you do my hints for number 4, but you need a little bit more. Think about some things you could do. Abby, remember, was not wrong to think that she could, distribute and multiply all those things out. It's just, that's probably not my first go-to option because it probably requires more work than some other options. So remember, x is a variable and you can choose different things for x as you wish. We have one more example, one with a quadratic, okay? So one final example. We haven't set this one up yet. Okay, so 5x squared minus x plus 27 all over x cubed plus 9x. You go ahead and do the first 2 steps for partial fraction decomposition. See what you get. Talk it over with your group. Compare your answers. See if you agree. First step is factor the denominator. How do you factor x2 plus 9x? Take out an x. Can you factor any more?
No.
Nope. So when you look at this, you see one of your factors is linear, x, and the other factor is quadratic. This one, x squared plus 9, can't be factored anymore. It has a degree of 2, so it's quadratic. How did you guys write your decomposition then?
A over x
A over x
plus bx plus c over x squared plus 9.
plus bx plus c over x squared plus 9. So anytime you have that quadratic, you need to have a linear factor on the top. Okay. Make sense? Good. Okay. All right. Step 3. What are we going to do?
Oh yeah, simplify.
Multiply the whole equation by my LCD. This time I'm just going to say, I'm going to put a big group of parentheses here and say I'm going to multiply the whole thing by x over x squared plus 9. Okay. And I feel pretty comfortable, like I can run through each individual fraction and decide what cancels and what stays. But in that very first fraction, everything's going to cancel out in the denominator, so I have 5x squared minus x plus 27, and there's no extra factors. When I multiply a over x by that least common denominator, only the x's are going to cancel. So I'll have a times x squared plus 9. And then when I multiply that LCD by my bx plus c over x squared plus 9, the x squared plus 9 cancels, but x remains. So I'll say plus. In this one, I'll put my linear factor bx plus c in parentheses because it's being all multiplied by that x. Okay, so we multiplied. If you feel like you need to write out next to each one, x squared plus 9 times x, x squared plus 9 times x, x squared plus 9 times x, do that. Okay, wherever your comfort level is, meet yourself there. Any strategies we could use for that step 4, solving for the constants? Let x equal 0. Okay, yep. Okay, so let's let x equal 0. On the left side here, we're just going to get 27. Then we're going to have a times 9 plus b times 0 plus c, but then that all gets multiplied by 0. So I hear people saying a must equal 3. Oh, how are we going to get b and c? It's a little bit different when they're in that linear factor, right? Is plus or minus 3, are those the zeros to x squared plus 9?
No, because it's a negative 9, you can't.
If you were to solve that x squared equals negative 9, you'd have to square root of negative 9 and your answers would be imaginary. Which is why it doesn't factor, right? Because if it was plus or minus 3, we'd get x plus 3, x minus 3. So what do we do in the last one?
But this time we have 2 factors.
Yeah, we didn't give up. We just plugged in our a, right? Last time we had 2 that we could at least plug in. This time we just have 1. That's fine. Okay, let's just plug in a equals 3 and see what happens. So I'm plugging it into, sorry, I didn't move that, and now I can't see anything. Plugging it into that simplified equation. So the left side is 5x squared minus x plus 27 equals 3 times x squared plus 9 plus bx plus c times x. Super helpful? No. We could think about Abby's method. Hers was to like distribute originally, and I said, oh, on the last one I said, I don't know that I would do that. It's kind of a lot of work. Is it as much work on this one? No, it's really not so bad. The last one I didn't want to do because you had to do x minus 1 times x minus 1. So I was feeling kind of lazy, and I thought there's something easier than that. But this one you could distribute and it wouldn't be bad. Okay, so if you want to distribute and see if you can figure it out, you could. What's another method we tried last time? Plug in a random x. So the only x we've tested already is let's let x equal 0. We could just say let x equal 1. So that would be 5 times 1 squared, 5, minus 1 is 4, plus 27 is 31, equals 3 times 1 squared plus 9, so that's 3 times 10, plus, and then it would be b times 1 plus c times 1. And do a little simplifying there. 31 equals 30, and then this is just b plus c, right? Plus b plus c.
Subtract 30.
1 equals b plus c. Ooh. If you get to an answer like this, where it's like one equation with 2 variables, that would mean, think back to what we've been doing the previous 3 days, you'd need another equation. Okay, so you'd need another equation. Then we would just go back to Grace's method, but we'd choose something different. Now we'll let x equal, which one? Negative 1? Yeah, let's let x equal negative 1. So then we have 5 times 1, which is 5, minus negative 1 is 6, plus 27, so that's 33, equals 3 times negative 1 squared plus 9 is 10. And then it'll be plus b times negative 1 plus c all times negative 1. Clean that up. 33 equals 30. This will be negative b plus c, but then it multiplies by negative 1, so it'll be plus b minus c. I'll get 3 equals b minus c. And then these are the 2 equations for your system. Works out kind of nicely because c will cancel or eliminate. So I'm just going to stack them and solve that 2 variable system over here. 1 equals b plus c with 3 equals b minus c. So 4 equals 2b, 3 equals 2. So then 1 equals 2 plus c, c must be a, yes, negative 1. And then I finally get to plug all that back in for my partial fraction decomposition. 5x squared minus x plus 27 x cubed plus 9x equals, and we said a, which we decided a was 3 over x plus bx plus c, so 2x minus 1 over x squared plus 9. It feels like a lot more work, but is it really that terrible?
No.
You know, I mean, it's the plugging in of the number, right? But it's not that terrible. Actually, on that one, Abby's method is a lot nicer. Yay, Abby. So it's like the first time I was like, let's not do that, just because I didn't want to foil. But here I made you solve the 2 variable system to see that you could do it. In Abby's method, if I go back up to that line before we went back to like choosing random x's, in Abby's method, let me find my thing, scrolly bar. right here, we could have said 5x squared minus x plus 27 is equal to 3x squared plus 27 plus bx squared plus cx. Right, I'm just distributing. You see this? Okay. And then notice like 27 and 27 match. Those are the constants. I have a negative x, and then all I have is cx, so c must be, what's the coefficient? Negative 1. Isn't that what we found?
Oh, because it has to be equal.
Yep. And then 5x squared on the left must equal 3x squared plus bx squared.
Oh.
So b must be 2. Isn't that what we found? So we would have had the same answer. Okay. I just wanted to show you both methods on this one. So like, if you forget about that, you have a method where like you can always plug in anything for x. And if you can find one constant, you could set up a system of 2 equations and solve for the others. So there's always that method, but you might try that sometimes. It might be easier. And I encourage working smarter, not harder. All right, that's it for your notes. You do have an assignment for tomorrow. It's 6 problems with partial fraction decomposition. I would do my odd problems first and make sure that I'm getting the correct answer in the book, and then I'll feel pretty confident about what I'm doing on my evens. Your problem set is due tomorrow. Hopefully you've been working on it so that if you have any questions, you can pop in after school. You could ask me before you leave today. The quiz tomorrow is only going to be over partial fractions. So we'll have some time to do a warm-up, go over homework, maybe do a couple of questions or examples, then start the quiz. There'll be like 3 questions on partial fraction decomposition. Your Chapter 7 test happens next Friday. I don't really have anybody on my schedule right now for Chapter 3 test retakes. So if you were planning to do a Chapter 3 test retake, I should be getting some kind of communication with you so that I know that's happening, because Tuesday is your deadline. We've got about 8 minutes. Let's get started on one on your homework. I'll write up what number 27, or sorry, 17 and